Okay, so hello everybody. Very glad to be here. I'd like to thank organizer for inviting me. And yeah, about myself, as just introduced, uh, yes, I'm the founder and CEO of Gina AI. So before that, I work at Tencent. So Tencent is one of the biggest internet company in the world. And I work there as an engineer lead, building the search infrastructure behind WeChat. And so WeChat is like a very popular social apps in China. And so I spent in Tencent for 2 years. And before that, I was working at Zalando as a senior research scientist there. And yeah, I got my master and PhD in Germany. So besides all these professional jobs, I also serve in some non-profit organization. For example, the Linux Foundation. So the Linux Foundation is one of the largest and the oldest open source initiative in the world. So some people may heard like Apache Foundation, Linux Foundation. So they are all very famous in the community of open source. And so a lot of people know me, especially those engineers from the computer vision, from natural language processing. So they know they probably heard me or used this kind of open source projects that I built. One is specialized this data set, and the other is word as service. So I'm the creator of these two open source projects. So short introduction about Gina AI. So Gina AI is a neurosearch company. We provide a cloud-native neurosearch solution powered by state-of-the-art AI and deep learning. And our company is fully, let's say, commit to the open source. So basically, everything that we do is open source, right? So you can go to our GitHub portfolio and look at all the projects that we are running in parallel and understand what we are doing there, right? And I think it makes sense to first show you, right? So what we are doing, and then I will talk about my observation or my understanding about the recent AI development in the last couple of years, and then we will go to the we will come to the question: what kind of characteristics do you need in order to run an open source company, right? And yeah, so basically, Gina is an open source solution which basically can use for all kinds of semantic search. That includes short tweet search, long PDF search, image to image search, video to video search, audio to audio, or any kind of document search, right? And so here is an example that basically show you, yeah, you can use that for feature extraction, you can use that for searching similar flowers, or search for using it for QA, the chatbot, a customer service. You can search for video. So basically, the query is a video clips, and then you search for all the related video clips from the database. Right. And the simple way to put Gina, right, to describe Gina, I always use this three kind of analogies. So first thing is we are building something that we believe is a TensorFlow for search, right? I mean, so TensorFlow is just a symbol, right? So TensorFlow is a very powerful, universal, open source software deep learning framework released by Google, right? And so what does that mean by TensorFlow for search? So if you look at the, let's see, the AI development, right, as an inverse pyramid, right? So at the bottom layer, we have the AI, let's say, computing infrastructure, right? So this includes CPU, GPU, FPGA, cloud service, embedded service, or even Raspberry Pi, right? So these are the hardware support, which plays as an infrastructure, right? So on top of that, we have this TensorFlow, PyTorch, and other deep learning framework. So these are the universal deep learning framework, which can, like, you can use that for recognizing cats from dogs, but also you can use it for like playing StarCraft or building a Go player, right? And so they are very universal, they are very powerful, but they are not tailored to search this kind of scenario, this kind of domain, right? So Gina is something that built on top of the universal framework and then provides the infrastructure for all kinds of search applications, including, let's say, tweet search, video search, image search, or even code snippet search, right? And this is how we're positioned. So we will come to this graph later. So when I explain my observations on AI development in the sequel. Yeah, these are the landscapes that we have, but I will skip this for now. If you are interested in getting to know what we are doing, so please go to get.gina.ai and then you can check it out by yourself. Okay, so now I come to the recent trends in AI development. So this is basically already, I write this in EC about 1 year ago, but still I think this is still valid. So the first observation that I realized in the, let's say in the last 5 or 6 years is that AI is becoming more and more about engineering, right? So if we think about, if you look at AI development, right, from two perspectives, right, so or from two axes, one is from 0 to 1. That means you build some very hardcore fundamental research on this theoretical machine learning, and then get new algorithm, new training paradigm. So this comes to 0 to 1 innovation. Right? For example, reinforcement learning is what I counted as 0 to 1 breakthrough. And the other thing is, or the other kind of types of innovation is like from 1 to 0. So in terms of AI development, from 1 to 0 usually means, yeah, we want to apply this AI model to different domains, right? And it's focused more on the reusability and engineering, right? Rather than, let's say, building something from scratch, right? I mean, these two kinds of innovation are equally important, right? They have to go hand in hand in order to push this AI community forward, right? But if we think about that, right? So back in 2012 or before 2012, this is the age where I called it pre-deep learning era or shallow learning era, where people still argue about the methodology behind artificial intelligence, right? So what is the best method to, let's say, to realize, to implement AI, right? They don't know, right? So a lot of things, a lot of methods are being discussed, including, let's say, Gaussian process, support vector machine, decision tree, this kind of thing, right? All this kind of method, right? So if you look at the papers, research papers that published back in the days, you will find a lot of clusters of scholars or researchers backing each kind of like a family of methods, right? So people argue, well, deep learning back in the time was already there, but it's not the, let's say, not the loudest guy in the party. It's just like a normal guy in the party, right? And yeah, so but after that, after 2012 or 2013, researchers and engineers began to realize that, okay, deep learning can really, let's say, outperform all the other methods, especially in the task on computer vision and also natural language processing, right? And so people agree, more and more researchers have agreed on the methodology, right? So they don't argue what is the best method to do this task anymore, right? So instead, they focus more on the engineering part. They start to think about, okay, so if it works on recognizing cats from dogs, does it also work in, let's say, self-driving, in autonomous driving, right? So this kind of thing this creates a paradigm shift. So a lot of research and engineers, including me, right, moving from 0 to 1 kind of fundamental research to the 1 to N AI engineering, right? This kind of innovation, right? So this is the first observation, right? The second observation is that there is an emerging AI supply chain, right, coming up, right? And so in order to understand this, I first need to show you this figure, right, this plot. So basically, if we look at the training cost, right? So basically, in machine learning, for those who don't know, in machine learning, we usually have to train the model in order to make this model, let's say, smart, right? The training usually means, let's say, remember the pattern. Yeah, it's like a simple word, remember the pattern, but there is a lot of mathematical things behind that. But yeah, we can say, yeah, I will let the model to remember the pattern, but the pattern can be very easy or very complicated. Depending on the powerful and the representative of the model, the model can takes a lot of times to can takes forever to remember the pattern if the pattern is overcomplicated, right? I mean, so if we look at the first deep learning model, the AlexNet, right, and compare this to, let's say, in 2018 or 17, Google releases AlphaGo Zero, which is like an artificial intelligence-based Go player powered by AI, right? Let me see if I get some questions. I hope not. Okay, and yeah, so if we compare the training cost between these two networks, right? AlphaGo Zero is more than like a 10,000, takes 10,000 times longer than the AlexNet, right? I mean, you can of course reproduce what Google does, but then you need to first you need to spend $100,000 to buy the GPU card, and then spend 3 months to train the model. That doesn't include the try and error, this kind of time you take, right? Often the case, you start with a wrong hyperparameter and then do this training for like 2 months and get this nowhere, and then you have to start again. Right. So this is a thing, right? So having said that, so the AI supply chain becomes more easy to understand. So if you see in the last 2 years and in the upcoming 2 years, you will see more and more people focus on less and less people, right, working on building a machine learning model from scratch, right, train a super powerful model from scratch. And what they deliver is what I call this pre-trained model. In the academia, they also call it like pre-trained model. And so most of the AI engineers or the AI community will try to make sense by using this. Will try to make sense out of this pre-trained model, right? How to make sense out of that. So basically apply your domain knowledge to this pre-trained model and fine tune this. And you basically, let's say you use some kind of fancy engineering skills to make it scalable, to make it servable like a SaaS service for for billions of customers simultaneously. Or you apply this from medical domain to, let's say, to the autonomous driving domain, right? This kind of a domain adaptation is also like a one-to-one innovation, and this can be done by standing on the shoulders of the pre-trained model. Okay, so the last graph is we already showed this again. So a lot of people will feel, let's say, especially individual AI developer or AI engineers, they will feel very frustrated because they think, okay, so let's say all the cake is that big, right? So most of the pieces in the cake has already been taken by those tech giants, and there's not so much things that I can do. Although I really love AI, I really want to contribute in AI community. Yeah, what should I do, right? But if you look at that, right? So there is still a lot of potentials and possibilities on the end-to-end application layer, right? So for example, if you ask the question, yeah, what do you use for deep learning back in, let's say, 2013 or 14, right? People will give you different answers, right? Like, yeah, I use Torch, I use Tiano, Caffe, deep learning for J, Chainer, this kind of stuff, right? But if you ask the same question again today, right, you will get more, let's say, more concentrated answers. TensorFlow, PyTorch, all the others, right? And so that basically means the market behind the framework layer is already, let's say, a red ocean, right? It is highly competitive. I hardly think you can run, you can just build a framework by yourself and from scratch and then go into this market. Even in China, for example, we have Baidu, we have this Paddle from Baidu, we have Miniscore from Huawei, but still we are pretty late in terms of cutting into the framework market, right? And but still, right? If you ask the same question, then what is the best open source library for machine learning, right? Or for image recognition? Well, you get different answer from person to person. So that is actually a signal that that is actually a signal where basically you get this market is still doable, right? You can still get you can still be a player in this market. Yeah. So I will just quickly go through the rest of the slides because I think I'm a little bit uh, like late. And yeah, so what do we need for the open source, right? Building an open source thing. I think there are 3 points which basically make a great open source company. So first thing is courage, and the second thing is open mindset. And finally, you have to work on the sustainability, right? And so in our understanding, open source is not just as simple as uploading your code on GitHub, to the GitHub, right? It is not about collecting stars on GitHub. It's more about, I mean, the efforts that you spend on is like 20% is about open sourcing the code itself, about 80% is all about open governance, right? So what does open governance mean? So open governance, basically, simply put, is building synergies between other open source software and make your project really sustainable in the long term. So usually the best open source software is not the shiniest, but the one that lives the longest, right? And well, to conclude my talk is yeah, so basically doing open source, I see a great future, especially when you are an individual developer, you want to contribute to the open source, AI open source community. So this is actually the best time. You get a lot of time, you get a lot of possibility, you get a lot of application areas where you can apply your knowledge into that. And to do this in open source, it really depends on your belief, whether you believe opening the AI infrastructure is the future. And it is what you actually believe in open source, what makes open source really is. Right? Okay, so that actually concludes my talk. And I'd like to hand over to the moderator. And yeah.